Sometimes when we factor, our quadratic expression is going to be missing a term, so we may be missing the b term or we may be missing the c term. So we can't use the British or box method to factor. What we want to do is divide out what the two terms have in common. So this could be a number, this could be a variable, or it could be both of them. So if I look at number 1, I have an 8x squared plus 4. So what I found is it's easiest if we break everything apart, especially the x's, so we can see exactly what we have in common. So my 8 has two x's with it. That's what the x squared indicates. So I have an 8 times an x, and then I have a plus 4 by itself. So if I look at the two numbers, 8 and 4, both of those can be divisible by 4. And my 4 has no x's, so it's not going to share any of the x's with the 8. So I'm just going to divide both of these by 4, so it's going to leave me with a 2x squared, and 4 divided by 4 is 1, so plus 1. Now the factor that I pulled out, that factor I divided by, the 4, just goes in front of the 2x squared plus 1. In number 2, I'm going to do the same thing. I'm going to write everything out, so I have a negative 3 and 4 x's, and I have a positive 12 with a single x. So if I look at the numbers, a negative 3 and a 12 have a 3 in common, and I'm going to divide by a negative 3 because we want that very first number to be positive. So I know I'm going to have a negative 3 in front of everything. And then if I look at the x's, the last term actually has an x this time, so I can eliminate an x from both sides. So it's going to be a negative 3x that both terms share. And now I'm going to write what they have left over. So a negative 3 divided by a negative 3 would give me a 1. And I have 3 x's, so this is going to be a 1x to the third. And then 12 divided by negative 3 would give me a negative 4, and all of its x's are gone. So it's simplified down to 1x cubed minus 4, and it had that negative 3x in common.